For the n-Lorem Foundation, N of 1 doesn't mean alone because every patient matters. Hope for nano-rare patients and their families has never been more within reach. Visit n-Lorem.org today to donate and make hope possible.
Welcome to the Patient Empowerment Program podcast. Today, we're bringing you the best of the 2024 Nano-rare Patient Colloquium. Before we start, a quick announcement. Stan will be recording a post-colloquium question and answer podcast episode. So if you had any questions that were not answered during the event, now's your time to ask. You could do so by emailing podcast@n-Lorem.org. That's podcast@n-Lorem.org. We're looking forward to hearing from you. Okay, switching gears. This year's colloquium spanned 2 perfect autumn days in beautiful Cambridge, Massachusetts, where hundreds of nano-rare community members from around the world gathered under a single roof to learn, connect with, and support one another. We're pleased to announce that the event welcomed over 750 attendees both in person and virtually. It's each and every one of you who made the event such a success. This impactful event was made possible in part by our gracious host, Biogen. We extend our heartfelt thanks to the entire Biogen team for their generosity and firm belief in our mission to bring hope and potential help through treatment opportunities to nano-rare patients for free, for life. Now, while we encourage you all to watch the presentations and panels in their entirety on the Colloquium recap page linked in the description, we took a handful of panel segments from the Colloquium and created this best of episode for our listeners. So let's get into it. Here's the best of the 2024 Nano-rare Patient Colloquium. n-Lorem exists for one purpose: to serve the nano-rare patient community. The perilous journey from diagnosis to treatment will show you exactly why we're powered by our patients and their families, and demonstrates that hopeless to hopeful is a possibility. Daphne Graskewicz-Prado is the mother of Harlow, a 3-year-old girl living with type 4A leukodystrophy. Harlow was accepted to the n-Lorem Foundation in early 2024 and at this point in time is awaiting treatment. Take a listen to Daphne share Harlow's diagnostic journey and detail their newfound hope.
All right, hi everybody. I am Daphne Graskewicz-Prado and I'm a mom of 3, but I am here to talk about my 3-year-old amazing daughter, Harlow. Harlow was diagnosed with type 4A leukodystrophy in July of last year. She presented normally as a baby, happy, seemingly healthy, big chubby cheeks. You could kind of see the curly hair coming in. But the only indication we kind of had was when she would get sick, she would get so weak, and it would take a while to bounce back. Once we started migrating towards 18 months, she was up, she was cruising, she was babbling, like she's just as effervescent now as she was then. So we would go into the doctor's office and I would say, but she doesn't have any balance. Like she's nowhere near taking independent steps. She's nowhere near just being able to stand. And having had, another child, not that much sooner, my son is 5 and she's 3. I knew what that progress was supposed to look like. And I had a similar experience to his wife where they said, kind of slid me the sheet. And I think all the women here know what the sheet is, the postpartum depression and anxiety sheet. They're like, are you okay? Because she seems fine. Because the doctors come in and they see him for 15 minutes, right? And she's up and she's cruising from chair to chair. And it seemed like she was okay. But I knew in my gut that she wasn't. So I kept pushing and persisting and eventually got her into PT. And they said, we have concerns that she might have CP. So then I went back to the doctor's office and perched on his desk and refused to leave. Until he ordered an MRI. So the MRI came back with less than normal white matter that you would expect in a 2-year-old. And they ordered the genetic testing out of Vanderbilt, which is a phenomenal institution, and I'm so appreciative to them. Then we got the phone call. And you look at the symptoms and you know what you pray it's not. And I'd gone through the TikToks and the Instagrams. I was like, dear God, please don't let it be leukodystrophy. Please don't let my baby be dying. And he called and said it was hypomyelinating, leukodystrophy 6, type 4A leukodystrophy, and I got tunnel vision. And he said I had to Google this before I called you because I've never heard of it before. And right now there's no treatment, there's no cure. But hey, a couple weeks ago, there was this nonprofit who came to talk to us here at Vanderbilt, and I don't know if they'd be able to help you. We're not equipped to take it on right now, but you should look up the n-Lorem Foundation. And we just so happen to have a connection to Amy and Stan, my husband's best friend from school growing up, that had just done a documentary that linked us up with Amy, and we did the video interview, and we're so new. I don't know if she knew that we were serious. She didn't know who she was dealing with quite yet.
No, and I did
not. And she said, yeah, we're gonna be at Global Genes next week. I didn't know what Global Genes was. I was like, oh yeah, me too. And booked a plane ticket and hunted her down. And stalked her at the booth multiple times. Ended up being able to meeting Andrew and her and going to the lab. And then you had the conference here not too much longer. And my daughter was like, please don't leave me again. My kids were like, oh mom, please don't leave me again. So my husband came out and we were still looking for a doctor. I had posted on LinkedIn looking for a neurologist to sponsor us for n-Lorem. My post got 600,000 views. No one stepped up to help. So my husband comes out to the conference, and it gets to the last day, and Amy walks up to him. She goes, did you find a doctor yet? And he said, no, not yet. And she said, well, a bunch of them just came off stage. Get over there. And I'm so sorry, Dr. Kim-McManus. You got caught in the crosshairs. And she is now referred to by my daughter, Harlow, as the pretty doctor. And anytime we're going to the doc, she asks if she's going to see the pretty doctor. We packed up our whole family, and we have moved to California just for my daughter's treatment. And she asks me all the time, she says, are we going to see the pretty doctor to get my medicine? And she says, Mama, I've got a 1-year-old who's 21 months old, and she's up and she's walking, and Harlow watches her, right? She knows what she should be doing because she's witty, and you can tell, with all these frilly dresses, like she is very girly and very opinionated, and she's my three-nager. But she looks at me the other day and she says, Mama, when I get my medicine from the pretty doctor, can I walk like Hope? And that's my 1-year-old. Stan, Amy, everybody. I can tell her maybe. I thought she was gonna die. I thought it was a death sentence, and because of you guys, I can tell her maybe. I can tell her that it's possible. Thank you guys for everything. Stan, you're changing the world. You're changing the world for me, for my family, for kids. Thank you guys so much. And to the parents out there who don't have a doctor, don't give up. It's hard. Don't give up. You are the voice for your children. Be fierce, be brave. Don't back down.
And if you want Daphne's number, I'll give it to you.
It's payback for the number of times I've handed out her email.
Thank you.
Ryan Strankowski is an n-Lorem patient for a condition which causes amyloid plaque to build up in his kidney through deposits of serum amyloid A protein, or SAA1, which leads to progressive kidney disease. While the vast majority of patients with kidney disease secondary to SAA amyloidosis respond to anti-inflammatory agents, Ryan's family is among the extremely small patient population who are non-responsive with little therapeutic options. SAA overproduction is presumed to be the main cause of renal amyloidosis leading to disease. The ASO medicine that n-Lorem designed and developed inhibits the production of SAA1 protein in the liver. Nelson Leung is his physician. Nelson is the David L. and Colleen B. Kessenich Professor of Multiple Myeloma. He is a consultant in the divisions of nephrology and hypertension and hematology in the Department of Internal Medicine at the Mayo Clinic. Listen to Nelson help give an idea as to the rarity of the mutation and hear Ryan discuss his thoughts and feelings of the treatment and how it affected his outlook.
So in medicine, we use the analogy horses, zebra, and unicorn. So kidney disease is horses. AA amyloids are zebras because they're pretty rare. Genetic forms of AA amyloidosis with the hereditary periodic fever syndromes are unicorns. Ryan and Kim are unicorns driving around in a Cybertruck. I mean, that's how rare it is. And
Got to get that in there.
I got to get that in there. They are the first in the world to have this mutation. In fact, when we were in a amyloidosis conference just 2 years earlier, and there was a panel on AA amyloid, the experts on the panel didn't believe our results that we actually found a mutant AA amyloid.
When you say that they're the only ones to have this mutation, you mean that specific mutation in that gene?
No, they are the first ones in the world to ever have a mutation in the SAA1 gene. Now, the SAA1 gene is a very peculiar gene. It is well preserved for over 400 million years. So it's been very well studied, and people have looked for mutations in this gene in the amyloid patients and never ever found one. So they are the very first.
Okay, so you get this information and you bring it to Ryan and Kim. What happens next? Well, first off, when you hear this, how unique you are, how did you feel about that?
To be honest with you, I was very happy because now we had a reason.
Yeah.
We had the cause.
This thing you've been looking for
Yep.
for, I don't know,
very,
how long?
very long time.
Yeah.
Yep.
Okay, so after the first dose, drops 80%. And when did you actually begin? Well, first off, the FDA helped set up this trial. You're going to be at N of 1, as we've talked about. When was your first dose?
We started that at the end of November, or the very first week of December of 23.
Okay, so about a year now.
Yep, just about a year.
Okay, so I don't know, were you anxious about this? I know this, so the other thing, this is delivered under the skin, right? This is not
Yes.
into the spine, right? So that, were you nervous about doing this? This is something that's never been put in a human being before, or did you just have complete faith in your physician, or what?
With the research that he was telling me about and all the work they've already put in, I was very excited. I wanted to, let's get this tested, let's see what happens. I wasn't nervous, even, okay, let's get ready to do this, we're starting it right now. I was just excited. Because it was just the work that was behind it.
Yeah,
So-
and this was, how long had we been waiting now at this point?
At this point was a year and a half?
Yeah, close
Yeah.
to 2 years.
Yep.
Getting through the FDA took some time. And then after that, n-Lorem had to finalize the formulation. Then I had to get my institution, the Mayo Clinic, to get the IRB, get the pharmacy involved, get the logistics. And so all in all, I think was about a year and a half when
Yep.
after I submitted the application.
Okay, so about a year in, what changes have you seen, and maybe what benefits have you seen, if you have, physically?
For me personally, on the physical side, probably a little bit better energy or a little bit better just kind of feeling. But for me, it was more of a mental thing than anything. Knowing that the kidney functions can get back to normal. Knowing that I can have just a longer normal life.
Yeah.
Knowing that with the little guy, well, I can see him till he's not quite such a little guy, or have his own even. Knowing that I can be around for that.
How old is he?
He is now 7.
7.
Yep.
And then,
So-
Nelson, what have you seen as far as metrics?
So what we've seen is that the kidney parameters stabilize. Now, with amyloidosis, the response is slow. So I wasn't expecting to see a whole lot during the first year. What we were mainly looking for is no deterioration, and that's what we're seeing. We're not seeing any deterioration. We're probably starting to see a little bit of improvement in kidney function. So overall, we've been pretty happy with the results because he's tolerating the therapy quite well, and we're starting to see some stabilization and maybe improvement in the kidney function. So he's coming up on a year. We're going to do a lot more testing at the end of the first year to look at some other stuff. But yeah, we're pretty enthusiastic and excited.
Luke Rosen and Megan Hedstrom are two parents of children who have KIF1A mutations, who, with sheer luck, are able to and have been treated with the same allele-selective ASO medicine by Dr. Jen Bain and her team at Columbia University. Luke is the father of Susannah, who is 10 years old, and Megan is the mother of Sloane, who is 3. Let's find out just what they've observed in their children after receiving treatment.
Okay, so it's been so how long since Susannah?
2 years.
2 years, and for
just over 2 years.
Sloane?
5 months.
5 months. Okay.
Almost 6, actually.
What have we
Next
seen with Susannah over those 2 years?
Oh, I mean, her cognition has improved beyond measure. I mean, well, not beyond measure because
It can be
they
measured.
spend their lives measuring things.
For different measures.
Different measures. But for us as a family, it's pretty amazing to see her, the way she's interacting with people, and that she made it through sleepover camp when her day usually ended at 2 p.m. because she was would get a call, she had a seizure at school or something happened. But she's making it through days, so she just has a happier life right now. She can, there was a word, Dr. Bain said, Susannah wears certain PJs to dosing that she just loves.
Yeah.
And Dr. Bain said the word, so that's so fashionable. Fashionable, was that right? 4 syllables?
Mm-hmm.
Susannah said the word fashionable. She could never say 4 syllables before. So
Did you say, like, I'm so fashionable?
Yeah, she repeated the word after Dr. Bain left, and I was like, yes.
In a sassy way.
In a very sassy way. But she could not communicate with that complexity. Yeah, now she has a scaffolding to explore things and to learn. She's learning things, which we never thought would.
The sleepaway camp, was somebody sleeping with her at night? Or?
Well, it's this really incredible sleepaway camp called the Southampton Fresh Air Home. So it's for kids like Susannah and Sloane and other kids. So she had a nurse and a para, but she had a fairly big cluster of seizures where they called 911 and had and she looked forward to this camp for so long, and she definitely would not have been able to go back and complete camp and sleep over had Dr. Bain not been on the phone with the ER doctors and with the camp and with all the advocating for Susannah to have this right and this experience that every kid should have.
The seizures happened at camp?
Yes, and so it really scared them enough to.
Said
so
we can't. We're not
raced over to the
to
ER and met them.
And Jennifer said, no, this can actually continue.
Or said, well, let's go home with.
Let's not talk about liability, okay? I spoke with the medical providers. I provided reassurance. We got her back to camp.
And she went back to camp.
Yeah, and she went back to camp. So Dr. Bain was thinking about her quality of life and how upset she would be if I ripped her out of camp when,
She just got there.
She's just
halfway there.
So she was again but having to take on the challenge of educating now camp nurses and camp doctors.
Right.
So,
I mean, I'm quite shocked by that. That 2 years prior, you would not have thought that was possible.
Her day was over at 2 p.m. Yeah. No.
I mean, how did she feel about being away from? Did you see her? Did you check in and see her every day, or she was?
Yeah, I mean, it was closer to home. We didn't check in and see her.
Wow.
And it was incredible. I mean, it was something she really wanted to do. And we were like, no way. But we didn't want to say that to her.
Yeah.
And so we said, yeah. And it was just like going into the unknown again. And now we know that she is this brave, incredible girl who can go to sleepaway camp.
I mean, I know plenty of kids who are normally developing who would not like sleepaway camp.
I hated sleepaway camp.
I loved it.
Okay, so 5 months for Sloane.
Yeah, so starting to see small changes, the tremors that have gone away, but stronger core strength. She's a more stable sitter. She crawls, she doesn't walk, but she's like so fast at crawling. One of the lifestyle things that I didn't know if we'd ever be able to do was send her to school. She started school.
Wow. So to prepare for this, I went back and listened to your interview on Stan's podcast. This was like 2 years ago. Wendy was on that podcast. Have you listened to that since?
Yeah.
I mean, I have to say that the tone was quite grim on that podcast. I was a little shocked. It was sort of like, Wendy would explain what maybe the considered natural history would be and would have to apologize to you for even saying these things out loud. I mean, the tone has completely changed 2 years in.
Yeah, I mean, and we just did a follow-up podcast with Dr. Bain.
Yeah.
And yeah, I mean, Susannah she still has a lot of challenges, but she was really very sick. Now she's really happy. She's still sick and still has challenges, but at least she's making it through the day. She's happy and she's able to have a conversation with her brother. And then again, I mean, excuse me.
Yeah, it's just meant a lot to your family.
Yeah, and to see my son be able to, to see my son be able to have a relationship with his sister that's not just being a young caregiver is meant a whole lot.
Yeah. Yeah.
Kelley Dalby is the mother of Connor, the first patient ever accepted at n-Lorem. Connor was born with a severe form of epilepsy caused by a mutation in the SCN2A gene. When he was diagnosed, she co-founded RajCon, focused on discovering therapies for SCN2A mutations. Connor's physician is Olivia Kim-McManus. She is an associate clinical professor at UC San Diego School of Medicine in the Department of Neurosciences. She's a pediatric neurologist and epileptologist, and she's the Rady Children's Hospital Precision Therapeutics Neurointerventional Program Director. Kelley and Dr. Kim-McManus discuss Connor's treatment experience, his dosing schedules, and how he has responded to his personalized medicine.
So can you sort of take me through what the first day looks like for that first dose? Connor comes in, has to be sedated. The injection's given. He's monitored for how long?
So he had some labs leading up to it,
Yeah.
and he has intrathecal delivery in the operating room under sedation, and so there's some labs that are done and vital monitoring before we go in, and then he gets dosed in the morning, and once he's coming out of sedation, we'll put on his EEG leads, do his EKG, and then he's monitored on overnight, and then goes home, and he's getting some measures in the interim as well.
Okay. Kelley, can you tell me about responses that you've seen in Connor or changes?
Yes. So I also want to just back up too and touch on his first dose.
Yeah.
So as I mentioned, he turned 15 in June, and this has been years of really nothing available for my son, right?
15.
Except the hope of what n-Lorem represents, right, in ASO. And it was a very long process, and I just want to touch on the day of dosing was literally one of the most exciting events that I've ever experienced in my son's life. And when he came out of the dosing, out of anesthesia, and he was in the recovery room, and he was still asleep, and he had EEG leads on his head, it was like such a moment. And I'm not really that emotional of a person, but I had tears in my eyes.
Yeah.
Olivia and I shared a moment, and it was like, we did it, like we all did it, like, and Laura, Olivia, there was so much that went into that. So that right there was just such a huge accomplishment for a child that had nothing else, no other chance.
But this is even before you know that it's going to work or not. It's just the fact that you have sort of climbed this mountain to where something is finally available to at least try.
And this ASO was in him, right? Yeah. And now let's see what it's going to do.
Right.
Mm-hmm. Right.
I remember that exact moment because he hadn't even woken up from sedation yet, and so we were just in the post-op recovery area, and you specifically had said that it was like one of the first times he'd been in the hospital with an EEG on and Connor sedated, but it was for not something negative necessarily. And so that's what was very different in being in that situation. And so we do have that on video too. So I'll show you guys at some point. Yeah.
I mean, it would be a terrible ending if it didn't actually benefit Connor, but I know that it has, so let's talk about that.
And I don't know that would be a terrible ending because...
Well, it wouldn't be an ending, but it would be, to reach this high of like it's in him, and if it didn't actually work, we have to do it again, right? So,
Because I think it's so important that the fact that you even have an N of 1 designed for a single patient who literally is just seen clinically as well, and then to deliver that on an investigational level, it's just that in and of itself is a feat regardless. So I think, because you can see how hard it is to implement anywhere. And so I think that's why Kelley says that as well. Yeah.
So he comes out, and what happens over the first month or two?
Well, I want to talk about expectations also, right?
Yeah.
So like Stan touched on is certain endpoints, right? So what is going to shift his quality of life? So ours were a reduction in seizures that we were hoping to see, and a reduction in his movement disorder. He has a very, very severe movement disorder that prevents him from doing a lot of things unassisted, non-ambulatory, so has never walked in his life, and nonverbal. We have a lot of other scales that we're using also as exploratory endpoints. And after the second dose, so 3 weeks after the second dose, his seizures stopped. His seizures stopped, and he started taking steps unassisted for the very first time in his entire life, and he's 15 years old.
So I think, if I'm remembering this, it's amazing, right? To put the seizures in context, I think it was something like 30 a day?
So that was in the first early years of his life, the first few years. So he averages about 1 to 4 seizures, tonic seizures a day.
As an adult, or as a teenager,
for the last couple of years.
And so that dropped?
Correct.
And he began to walk?
He began to take steps unassisted. So he got up to about 50 steps all by himself. And he has never taken steps by himself before.
I mean, amazing. Olivia, do you want to add anything to that?
Yeah, that was incredible and not really something that we were expecting. And it was a persistent and consistent thing that we were seeing after dosing week to week. And as we had touched on, Stan touched on earlier, in that even that was like low dosing, very low initial dosing. With the FDA, we had like a certain trajectory of dose escalation, and even that, because of his specific variant, we were increasing dosing more slowly, and even there, we were seeing that change. And so it was very interesting to see and unexpected, and it was also interesting that as the dose interval kind of continued and the symptoms, his ability to walk kind of wore off. And so that was very interesting to learn about ASO effect.
Yeah.
Right. Okay. So that was after the second dose, you said?
3 weeks after.
So have you seen continued improvement since then, or is there a plateauing that you've experienced?
It's not necessarily a plateau. It's what Stan touched on in his introduction, right? So all of these are novel gene targets, right? Almost unique programs. And so it's figuring out, my son is a true pioneer. We're learning about the SCN2A gene mutation from Connor being dosed with this ASO. And we've had to dose increase very slowly. Ion channels are very sensitive. And we've had to go even slower based on what the FDA recommended his dose to be, slower than what the original protocol was designed. And so the current dose level the effect does not last 3 months in between doses. So for example, his last dose was in August. 3 weeks after his dose in August, his, again, seizures stopped. He started walking again, and just this past Saturday, his seizures came back. So the effect has lasted about 2 months. And really about the last week, he's not taking steps very well by himself anymore. So it's just a matter of the next dosing period, we're going up again. We're increasing the dose. So it's just, Connor's gonna tell us, does going up in dose now last the full 3 months, or what do we need to change? It's just, I guess it's constantly learning from the molecule through Connor on what the next step is.
There's no thought, I mean, I know that this is a trial, but keeping the dose level the same, but just increasing the frequency?
We could, right? But also what is possible the higher we go, right? So.
Right.
I mean, there's always that discussion about, because ASOs have long half-lives that are months long, and so we want to see, we're already scheduled to dose escalate in a couple of weeks here, and so we're very still low dose, I would say, at this point, so there's both options to increase dosing and change intervals.
Creating, developing, and providing personalized ASO medicine for an individual patient is only part of the challenge that faces n-Lorem and our patients today. Our physicians and institutional partners are key to ensure that not only our patients are cared for, but that they can access treatments we offer. In the panel Building a Nano-rare Network and Managing Institutional Challenges, institutional partners and physicians working with n-Lorem addressed a challenging question. How have they managed to overcome obstacles when persuading their medical centers to partner with a first-of-its-kind nonprofit and bear the costs needed to provide treatments for nano-rare patients who have been overlooked and have no other therapeutic options? Julie Ziobro is an assistant professor of pediatrics in the Division of Pediatric Neurology at the University of Michigan, and Horacio Kaufmann is the Axelrod Professor of Neurology, Professor of Medicine, and Professor of Pediatrics at NYU Grossman School of Medicine. Here's what they had to say.
I'm Julie Ziobro. I'm a pediatric epileptologist at the University of Michigan. And our program right now is a little bit earlier. We haven't actually delivered the drug to the patient yet. It's still in discovery. But in order to put in an application with n-Lorem, there is a section on there that says that you have institutional buy-in in order to make sure that the drug is going to be able to be delivered to the patient once it's developed. So to get through that process, I guess, as a relatively junior faculty, I had no idea where to start in a very large academic center. So I definitely enlisted help from multiple people. So this has very much been a team effort. So shout out mostly to Louis Deng, who's been my kind of co-PI in this situation. But we also dragged in a couple of our senior colleagues who have an interest in trying to move ASO therapies forward as well. And essentially, to get the institutional buy-in, we started with the Dean for Clinical Research, and she also didn't know how to do this, but she knew all the right people. So she was really a good stepping point where she basically said we just have to get everyone in the same room, and she set us up a meeting with the chief medical officer of the hospital, the chief financial officer, and then some of the other academic clinical trials leadership as well. And before we're going into that meeting, I think we really tried to do our homework first. So we met with the n-Lorem team. We talked with Liz, we talked with Jen, just to see how they had done this at their institutions, so that we could go into the meeting with kind of as much knowledge as we could present to hospital leadership before to go into this process. So we presented our case, we presented the methods behind ASO therapies, and then we really tried to explore what we would anticipate as the risks and the benefits, not only from the patient standpoint, but also from the hospital standpoint, financial standpoint, and then also just the benefits of potentially being a leader in moving medicine forward, which is part of the hospital stated mission. And I will tell you, I think the CFO probably asked the most questions, and I think he asked me 3 times how much the drug R&D was going to cost the hospital. And I think he was shocked every time when I said nothing. So that was a big selling point from their perspective. But essentially they went back and ran their numbers and then and gave us a decision that they were happy to support it, which is great. So we're kind of waiting for the next steps to really see how this works to be able to hopefully move forward with additional patients.
My name is Horacio Kaufmann. I'm a neurologist, a clinical neurologist at New York University at NYU. And we have one patient with familial dysautonomia, that's a single point founder mutation, that is currently receiving an ASO that was designed to correct the splicing defect. It's the 4th, next will be the 4th dose of the ASO that is given intrathecally. I was thinking this morning how to summarize the challenges to make this happen, which took a long time. And perhaps I thought in three principles. Number one, the FDA is not the Vatican, meaning they do change their opinion if you refute an initial. We had 3 refusals and 3 no's saying we couldn't do it, and finally we got it approved. So remember, if they say no, don't take no for an answer and keep arguing. That's probably number one. Number two is that every institution, at least the ones I know, particularly the ones that are supposed to be the best institutions in the US, have been infiltrated by middle management whose job is to say no. Whatever you say is going to be no. There are now 3 to 4 to 5 administrators per investigator. The job of these administrators nobody knows. I think that their main job is to say no. So do not take no for an answer, because you could convince them, right? And the third is rely on use n-Lorem resources. This is an incredible organization. I have worked over the years with many foundations. I don't think that any foundation compares to n-Lorem. And perhaps the big difference between n-Lorem and others is that most foundations are, they only care about the financial part. They give you the money or they don't give you the money, and then that's it. n-Lorem actually is, I think, is closer to a program officer for an NIH grant, meaning they do support what you do, and they have been incredibly helpful, not only in refining the protocol and helping, also in the relationship with the FDA, and essentially they have been extraordinary. They do help with everything, and they have a team that I think is equal or better than program officers at the FDA. How is this paid at the institution? I think it remains a mystery. And I think it's better to keep it that way. When the institution asks you, well, what would happen if there's a complication? Who would pay for that? I think the best way is to go around in circles and essentially give no answer, because nobody knows who would pay if there's a complication. So keep it like that, hope there are no complications, and keep going forward. Keep the high moral ground. What you are doing is not for your benefit, it's for the benefit of somebody else. And whoever says no is really preventing helping a patient. So keep that high moral ground, because you have it when you want to treat a patient. Keep going forward, be inappropriate if you have to be inappropriate, but don't get fired.
As n-Lorem scales to meet an ever-growing demand, new challenges arise. Many of these challenges will take innovative solutions and support from leaders and experts in a variety of different fields. Together, as a community, we are creating a path forward for nano-rare patients and changing the way that genetic diseases are treated. In the panel Innovative Ways to Support Nano-Rare, the discussion touched on how economic models could justify the cost of treating nano-rare populations and potentially shift the status quo by molding the economic perspectives of both the government and insurers. Andrew Lowe is a professor at the MIT Sloane School of Management and director of MIT's Laboratory for Financial Engineering, and Alan Lotvin is CEO of Sequel MedTech and former president of CVS Caremark. Here's what they had to say. Take a listen.
Andrew, you mentioned financial engineering, and which is key because, like when you think about 1 million, 1.3 million, like it's a lot of money. And I know in Europe, some governments will say, especially in the UK, if you look at it in the UK, sometimes, and we talk about that, it's sometimes terrible to say, but they prefer not to treat a child than treating him because it costs more money to the system. So I'd like to get your view on that, Andrew, based on your experience and in the US and outside the US.
Well, yeah, this is a very complicated question because, of course, money is not the only thing at issue here. There's an ethical dimension that really doesn't afflict many other industries. The way that the United States makes decisions about risk-reward trade-offs, particularly when it comes to human life, is a concept called the value of a statistical life. When you set the speed limit at 55 versus 45, people will die. every year. More people will die. And so how do we decide 55 versus 45 versus 85? And the answer is that the value of a statistical life is a concept that the Department of Transportation and other parts of the government have come up with to use as a way to make these economic trade-offs. And as of last year, the value of a statistical life here in the United States is approximately $13 million. That's the number that we use for entire human lifespan, so that when you think about the number of lives lost, you put a dollar figure on it and balance that with some of the benefits of your particular piece of legislation. So $13 million per life. What does that mean for a drug that will create a totally healthy child for an entire lifespan, and it costs $2 million? In my view, that's a bargain. In the calculus that the government uses, that's a bargain. The issue is how we make that narrative more explicit when it comes to government policy, specifically for the therapeutic development of these diseases. So I think there's a lot of possibilities to improve the situation for rare, ultra-rare, and particularly nano-rare diseases. But we need to start looking at it not just from a purely ethical dimension, but to actually use the government's own language to convince them that actually this is going to save costs and will be in the best interest of the country, given all of the other competing interests that are vying for dollars from the federal government.
So it's so interesting, Andrew. I was actually going to ask you the question because, again, I'm always about trying to figure out how do you use the system to fix the system, right? And so sometimes you can, sometimes you can't. But and again, I'm not a lawyer, but you sit there and say, you're right. If I'm going to make a $13 million decision on whether to fix a road or not fix a road, I should make the same decision about whether to cover a drug or not cover a drug. And there's plenty of ways in the United States to get things to be handled, at least what is perceptually fairly. So again, that's why, like, how do we as an organization, right, not just lobby, but literally use the system to get equal. There's a whole constitutional amendment around equal treatment under the law, right? So if you could make the argument this is vastly unequal treatment, right? Just because everyone wants to speed and not everyone has a single base pair mutation doesn't make a darn bit of difference in the context of equal protection under the law. So like those are the sorts of arguments and we have to make, not just as an emotional appeal in my opinion, but literally as a way of changing policy.
The n-Lorem Access to Treatment Committee, known by the acronym ATTC, reviews applications to n-Lorem submitted by research physicians and provides recommendations on whether to accept or deny the case based on a variety of different factors like ASO amenability. Meanwhile, the Data Safety Monitoring Board, DSMB, provides safety oversight through the interim monitoring of accumulated data from all studies evaluating n-Lorem ASO medicines. And the Study Treatment and Assessment Review Committee, or STAR Committee, plays a critical role in supporting n-Lorem and the physicians treating our patients. This committee offers expert guidance in developing treatment goals and clinical outcome assessments, tailored to meet the unique needs of n-Lorem's diverse patient population. Because of such diversity, things aren't always black and white. In the panel Changing the World One Patient at a Time, committee members were asked about some of the challenges that they face while making decisions. Take a listen to some of these challenges described by Toby Ferguson, an ATTC member and Chief Medical Officer of Voyager Therapeutics, and Liz Berry-Kravis, co-chair of the STAR Committee and a professor of pediatrics and neurological sciences at Rush University Medical Center in Chicago, and Eugene Shneider, DSMB chair and executive vice president and chief clinical development and operations officer at Ionis Pharmaceuticals.
Yeah. I think there's a general frustration with timescale. Mm-hmm. And even ASOs, which are highly efficient and probably one of the quickest therapeutics to develop, there's still it's a months process, maybe a year process. And that's always still a little frustrating. I think particularly on the ATCC, and we're having these discussions about sort of, is there an ASO approach? What is the risk benefit? We're often confronted with, despite what we think is a wealth of knowledge, a lack of knowledge. And so that discussion about, do we have an appropriate strategy with an ASO? Do we know enough to say this is loss of function or gain of function. We're always bumping up against that. And it's both enjoyable but also frustrating because you don't always have enough information to sort of move forward. And so it's exciting to sort of try to accrue that knowledge, but it's also frustrating that sometimes you have to say no when you don't have the answers you need. You have to go out and get more data.
Yeah, I want to add on to, as a member of the STAR committee, I think you get a patient in and there's no standardized outcome measure that would be appropriate for that patient, and you're trying to think of what would measure improvement in this patient, like how will we possibly do this? And then, people come up with novel ideas. Some of the clinicians have come in with really, really good ideas, but at the same time, like you want to have something that's kind of accepted and standardized, so you have to do a mix of things. And I think that's been, a real challenge, is how do we match outcome measures that are made for the typical population to our very atypical populations, and how do we be creative enough to come up with things that will be meaningful to families, as well as convincing that there's, really an improvement. And then I think, in addition, managing expectations, because many people say, oh, we're going to correct the genetics and then basically it's going to be a cure. And it's, as Stan said, it's not going to be a cure. What we're looking for is a better quality of life, an improvement that will be clinically meaningful, but we don't know how much that can be. Like, we don't know how dramatic that can be.
Point, yeah. What I heard you saying is a lot of times the outcome measure we have is, in a typical clinical trial, we want to make sure it's fit for purpose. We know the top and the bottom, but with these individual patients, we're sometimes way off. And they surprise us. I think maybe I don't know if you want to mention anything about other trials you're involved with, but I think there's been a lot of surprises with ASOs and gene therapy, patients doing things we never expected they would start to do.
Well, one example, again, sorry to bring it back to Spinraza, but one of the very first kind of strange things that we kept hearing was that the LP procedure is becoming more difficult because you need a nurse to hold the baby, where
those
you
darn
didn't
patients
before.
are getting stronger.
And then you needed 2 nurses to hold the baby before you could administer. So again, there was no scale that was used to measure that. But once you start hearing that more than once from several sites, there's something that in your mind begins to shift, and you think, how do we convey that back to kind of the qualitative data that you oftentimes are surprised or you're just not thinking about. That's
The challenges presented by nano-rare patients are far too complex for n-Lorem to solve even a fraction of the issues without support. Thus, our goal from inception has been to build a broad and effective network of contributing stakeholders. In the panel, What It Means to Partner with n-Lorem for Nano-rare, they discussed what more their organizations can do to support Nano-rare and how partnering with n-Lorem provides their employees with a feeling of purpose. Biogen is a founding donor of n-Lorem, and today they continue to support by donating time and providing knowledge to our team. Biogen has been an exceptional partner and has graciously hosted both the 2023 and 24 Nano-rare Patient Colloquium. We extend our heartfelt thanks to the entire Biogen team for their generosity and firm belief in our mission to bring hope and potential help through treatment opportunities to nano-rare patients for free, for life. Hear from Kate Dawson, Biogen's Senior Vice President of the Therapeutics Development Unit, on how contributing to n-Lorem's mission has made an impact within the Biogen organization.
Yeah. So Kate, I wonder if you could speak a little bit to how potentially this has impacted or whether it's impacted, had the impact at Biogen.
I think it has, definitely. Rare diseases is part of our focus at Biogen. We've already talked, I think Natasha was here talking about SOD1 ALS, and we should shout out to Toby Ferguson, who was here, who led that program for many years. There are very few patients, but there's still more than 1 or 30, right? And, we don't have a business model that works. It was very interesting to hear some of the other speakers think about how we might be able to tackle this differently in the future. But right now, for a company like Biogen, we actually can't design development programs for that small number of people and make it work for us. But we know that they still have diseases and they deserve an opportunity, especially given the advances in genetic testing and the fact that we can make these precision medicines to actually transform lives. And I wasn't able to attend in person yesterday, but was online and listening to the impacts of some of the therapies of the patients that are, and we know it changes lives. We see it with tofersen and nusinersen. So it's a real core tenet of the Biogen, people at Biogen, that they want to make a difference, they want to tackle these difficult diseases, and it's a matter of equity and social justice that these patients should also. So I think it's a source of pride to know that we're continuing to partner with n-Lorem and help them along the way.
Yeah, well, thank you for that.
To finish off, let's hear from Stan Crooke, the founder and CEO of n-Lorem, and the host of the Patient Empowerment Program podcast. Stan gives a look at n-Lorem's progress to date, plus our safety and tolerability profiles, and details why they are unblemished. Stan also gives an extremely positive update on the benefit observed in n-Lorem patients who are evaluable for benefit. Give this a listen.
Okay, what about safety? Well, our safety database today is pristine. We've now filed and had approved 21 INDs. That, for those of you who don't know, an IND is a patient's life. It's a family. It's not just a piece of paper, and it's an enormous amount of work. So that's almost an IND a person at n-Lorem. We're very proud of that. 29 patients now are subject to these INDs. We're treating 14 patients, and by the end of the year, we hope to be treating about 25, maybe a little less than 25. 25 families who otherwise would go untreated. Otherwise untreated. We have about 8-year total patient experience. We've administered more than 65 doses. We have our longest patient, who's Susannah, who's out 2 years and still benefiting in a meaningful way. But we have quite a number of patients now that are longer than a year. So we have longitudinal experience that says we can do this safely. If it's done properly, we can do this safely. And as I say, pristine safety and tolerability to date. No serious adverse events. In fact, no adverse events that are clearly ASO related, but that will change. I mean, these patients are ill. There will be adverse events that we don't know whether it's ASO related or not, but we're off to a great start, and that's really important in terms of supporting the FDA as well. Okay, how do we do it? Well, you have to be vigilant, and you need experience. And among the experiences you need is you need to know this technology. ASOs are complex biochemically active molecules, and done properly, they are wonderfully safe and well tolerated. But the difference between an optimal ASO and a suboptimal ASO is the difference between good news and bad news. And so doing it right means that you need experience. You don't need experience for any particular step. You can read a review and get that. But what you really need that experience for is the judgments. Is this the right patient to treat? Is this a good enough ASO? What is the right dose? What should we watch for? How should we handle that patient? And we're making experimental medicines. And so you need to know something about drug discovery and development. You need to know a lot. How to do clinical trials, how to manage these patients in the clinic. And then, of course, you need regulatory experience. We need, of course, the best approach to identifying the best ASO. And we think we have that. We think we have 35 years of experience and tens of millions of ASOs at our disposal, and we think that really matters. We've industrialized the systems and introduced multiple extramural quality control systems into the process. And I'll walk you through some of those committees and what they do and why they're important. And we're cautious. And finally, we collaborate with outstanding research investigators. And those conversations happen constantly as we're dealing with patients. And those are all essential to doing this in a highly effective fashion. What I'm pleased to tell you is that to date, we have 100% success. It's biased in our favor. We're dealing with genetic diseases and we're making genetic drugs to treat the genetic causes, but it's still surprising to me that we have every patient who's evaluable for benefit is receiving significant benefit. And these are not trivial benefits. As you'll see in video after video and all kinds of information, these are significant improvements in multiple symptoms and behaviors and characteristics. We see prolonged benefit. These are not short. We have enough patients now treated for more than a year that we can speak to the chronicity of the benefit that we're observing. We're seeing benefit in more than one organ, benefit in the central nervous system, in the eye, in the liver, in the kidney. So we're not simply doing a particular organ. And in the central nervous system, we're seeing doses that are surprisingly low produce really quite remarkable benefits. We are seeing improvements in multiple domains, even including things like pain and autonomic dysfunction, which is extremely encouraging. And we're seeing recovery of function after function after function that not long ago we would have thought was simply impossible. So these are benefits that you don't need a caliper to measure. You can see it, and you can measure it, and we have. For all the people who said to me, this is impossible, I can say unequivocally, you're wrong. We can do this. We can do it well. And to get here, we've overcome barrier after barrier after barrier. And there will be challenges ahead, of course, but the single barrier that remains is funding.
That's it for this best of the 2024 Nano-rare Patient Colloquium episode. You could rewatch the entirety of the event by clicking the Colloquium recap link in the description below. There, you'll also be able to read more about each of the Colloquium participants by clicking on their headshots. Also, as a reminder, if you have questions for our upcoming question and answer episode, please email them to podcast@n-Lorem.org. Be sure to subscribe to the n-Lorem Foundation's YouTube channel and follow us on social media to get all the latest updates. With the Patient Empowerment Program podcast, n-Lorem is building a Nano-rare community, so be sure to follow us on your favorite podcast listening platform to never miss an episode. I'm Andrew Serrano for the n-Lorem Foundation, and have a wonderful rest of your day.